Welcome to The Ghosts of the Abyss, a deep dive into Grimpoteuthis. In the crushing darkness of the Haddle Zone, where pressure exceeds 1,000 atmospheres and sunlight never reaches, life truly finds a way. This presentation will tell the incredible story of the deepest living octopuses known to science, thriving in unimaginable conditions, at depths of up to 7,000 meters, temperatures around 1.5 degrees Celsius, and pressures over 10,000 psi. Let's talk about the Dumbo phenomenon. This creature earned its whimsical moniker from the 1941 Disney film character, due to those prominent ear-like fins extending from its mantle. Its appearance is often described as cute or resembling a stress ball. But the reality is far more formidable. These are apex survivors of the Haddle Zone, and they're not always tiny. The largest recorded Grimpoteuthis was an estimated 1.8 meters, or approximately 6 feet in length. Grimpoteuthidea belong to a truly distinct lineage within the order Octopoda. While most common octopuses fall under Incerata, our subjects are part of the Sirena, or finned octopuses, which includes genera like Grimpoteuthis, Cryptoteuthis, and Luteuthis. Their unique features include fins supported by an internal U or V-shaped shell, optic nerves that bundle as a single unit to each eye, and finger-like projections called cirri located between their suckers. These octopuses showcase remarkable anatomical adaptations. Their internal shell anchors large fin muscles, essential for swimming. Their semi-gelatinous body consistency is perfectly suited to withstand the immense hydrostatic pressure of the deep. Extensive webbing between their arms allows for a unique umbrella feeding technique. And notably, they have no ink sac, a feature that would be evolutionarily useless in the total darkness of their habitat. These are truly the deepest living octopuses, venturing right into the Haddle Zone. They thrive in incredibly cold temperatures, ranging from -0.72 to 0.10 degrees Celsius, confirming their habitation in a zone where few other complex organisms can survive. Their habitat range begins at 1,000 meters. We've seen average abyssal depths at 3,800 meters, a confirmed sighting in the Java Trench at 6,957 meters in 2020, and even a controversial record off Grand Cayman at 7,279 meters, with some reports suggesting they might even reach 8,000 meters. The Dumbo octopus exhibits a fascinating art of movement that is deeply intertwined with energy economy in the deep. Their primary mode of travel is fin swimming, where they flap their large, ear fins to generate thrust. They can also use pumping, contracting their webbed arms to push water, and crawling, employing their arms to navigate the seafloor. This fin propulsion is crucial, helping them to conserve energy in their extreme deep-sea environment. These creatures are effective hunters in the dark. Unlike their shallow water cousins, Grimpoteuthis swallow their prey whole. Their hunting strategy involves spreading their arms, enveloping their target, handling it, and ultimately trapping it. Their diet primarily consists of polychaete worms, copepods, amphipods, and various crustaceans, all part of the limited food chain in the abyss. Their reproductive strategy is a unique, solitary cycle, perfectly adapted to the abyss. With no seasons in the deep, females engage in continuous spawning, carrying eggs in various stages of maturation year-round to maximize rare reproductive opportunities. Males lack a specialized hectocotylous arm for sperm transfer, instead using enlarged suckers to pass sperm packets, which females then store until conditions are perfect. The eggs themselves are remarkable, encased in a tough shell we call them iron eggs, that hardens on contact with cold water and are attached to deep-sea corals. Hatchlings are born ready, emerging as fully competent juveniles, prepared to hunt immediately with no parental care. In 2021, a new species, Grimpoteuthis imperator, or the Emperor Dumbo, was discovered. What's truly groundbreaking about this discovery is that it's the first species described using only non-invasive techniques. Through micro-CT scans and 3D imaging, scientists were able to preserve the rare holotype specimen while still revealing its internal shell structure and organ placement. This incredible find was made in the Emperor seamounts of the North Pacific. Behavioral breakthroughs have also shown us the fascinating, vertical commute of species like Ceroteuthis muelleri. These octopuses demonstrate energetic coupling by moving between the pelagic and benthic zones. They drift in the pelagic zone, 500 to 2,600 meters above the seafloor, to save energy, then descend to the benthic zone to feed. This behavior effectively connects the energy systems of the open water and the seafloor, as they go miles down for lunch. Grimpoteuthis species exhibit a wide, global distribution. We find them in locations such as the Azores, off the coast of Oregon, in the Java Trench, around the Philippines, and near New Zealand. Our species roster includes G. bathanectes in the North Pacific, G. umbellata, the type species from the Atlantic, G. woolcary in the Arctic and Atlantic, G. boyley from the Porcupine Abyssal Plain, and the recently discovered G. imperator from the emperor seamounts. It's important to remember that their taxonomy is fluid. Many species are known from single specimens, and reclassification is common as new data emerges. When it comes to defense in the deep, these octopuses employ a unique survival strategy. They have notable vulnerabilities: no ink, and unlike many shallow water cephalopods, no camouflage as they cannot change color. Their threats include predators such as sharks, teleost fish, eubacia, and even sperm whales. However, their ultimate shield is depth itself. By living at 1,000 to 7,000 meters, they exist beyond the reach of most predators. Consequently, they face few direct threats from humans, largely due to living at depths of 1,000 meters and below. Let's summarize the Grimpoteuthis profile. First, their habitat: they are the deepest living octopuses, found at around 7,000 meters. Second, locomotion: they rely on fin-driven swimming and gliding, rather than jet propulsion. Third, anatomy: they possess a U or V-shaped internal shell, optic nerve bundles, and cirri. Fourth, feeding: they swallow prey whole, with no need for beak tearing. And finally, reproduction characterized by continuous spawning, large eggs, and no parental care. The Dumbo octopus truly represents the last frontier, the mysteries still waiting in the 99% of the ocean we have yet to explore. As technology evolves from traditional drag nets to advanced ROVs and CT scans, we are slowly but surely uncovering the complex lives of these enigmatic ghosts of the abyss, revealing the secrets of an environment few have ever seen. Here are the sources that informed this presentation. We utilized information from Wikipedia, various research papers by Golikov et al. And Ziegler and Sigourney, as well as cultural context from News Penguin and Namu Wiki. Images were courtesy of Wikimedia Commons and Royal Society Publishing. Thank you.